Okay, so this is part 2 of the video that we were making about what ions and ionic bonding is. So we already know that if it has the same number of protons as electrons, it's an atom. If it has a different number of protons and electrons, you can either have a negative, depending on if you have more electrons, or a positive if you have more protons, and these are called ions. They're charged particles. And we want to make these because we all want to look like the noble gases, because the noble gases are the most stable. So now we have to look at the two types. So we're going to look at the positive and we're going to look at the negatives. So your positive ions are going to be called cat ions. And I love that term. And I actually love how cute this cat is right here. So we're going to start with topic 3. So they're looking at the two types. And you've got the happy cats. These happy cats are positive. Positively charged ions are called cat ions. And it's pronounced cat ion. It's not caton. It's not onion. I mean, you guys never really actually turn on your mic, so I'd never actually hear you say it. But it's pronounced cat ion. Two separate things. So they all give away electrons so that they can be positive. They are much happier having lost electrons because they didn't have very many valence electrons to start with. Okay? Happy, happy, happy cats. So if you're feeling negative and you get rid of some of your negativity, you become more positive. It also goes the other way. If you're positive and then you take in the negative, then you are going to become more negative. And so that's what happens when you become an angry ant. So your negatively charged ions are going to be your angry ants or your anions. Anions. So these are our negatively charged ions are called anions. And they have taken in some electrons, so some negative particles, and then they have therefore become more negative. And as you can see on his face here, he's not super happy. They've become a little bit more upset with the world. Not super happy at all. So, one more thing. I'm going to go back to this. So your cat ions, in this box underneath the cat ions, these are generally your metals. Your metals become your cat ions. They're on the left of your staircase on the periodic table. Your anions are your non-metals. They're on the right of your periodic table. So that's also an important add-in there. All right, so now, which atoms give and which of them take? So I guess we're just going to do exactly what I just told you now. So this is which atoms give and which ones take. So metals act as cat ions, so they become our positive. And nonmetals are anions. So the cat ions here, they're giving the example, they're like hippies on the periodic table because they're going to give away their electrons. Because they're giving away all the love. They're giving them away, giving it away, giving it away. And then the anions are greedy because they want to go around and take all the valence electrons they can from other elements. So they are definitely going to take in all that they can all the time. So what is an ionic bond? So ionic bonds are going to form when one atom gives up the electron and the other atom takes it in. So both of them become charged ions and therefore they bond together. So that's this part right here. So ionic bonds form when one atom gives up one or more electrons to another atom and they both become charged. So we'll show you how that works exactly here in a second. This bond is a super strong bond. And it's very strong because you have electrostatic attraction between these two. So that positive and negative charge are going to hold each other together and they're going to link up because of that. So you end up with linking ionics with opposite charges together. So this is really important in how you do it. So we're going to give an example. So you've got here, this is your lithium. 3 protons means lithium. And you've got 7 on the outside, but 9 total. So you're going to have 9. This is wrong. 7. No. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 9. So this is fluorine, which is fluorine here. Sorry, this is 9 protons. Sorry, that's a mistake. 9 protons. Fluorine, 9 protons. 7 valence electrons, which is I think what the 7 was meaning up there. So 7 valence electrons, and this has 1 valence electron. So this wants to get rid of the 1, this one wants to take 1. So this one sends over its electron and says, here, you can have it. I'm going to give it to you. So you now have 8 on the outside, 2 on the inside. So you have 9 protons and 10 electrons. So you're an ion. Here we have 3 protons and 2 electrons, so we are also an ion here, and this will become lithium fluoride. All cations keep their same name, exactly the way that it was before. All anions end in IDE. So that IDE is very important at the end of fluorine. There we go. I think that fixed that a little bit, trying to focus that a little bit. So fluorine will become fluoride. So it just gives you the example here. This one becomes a cation and this becomes an anion because they're positive and negative. All right, so what types of ions do the different elements, and we kind of have gone over this already, elements form? So the table shows the most common ions are formed when they give up or they take electrons, and it can be written on the top. So we've talked about this, or I've talked about this in a couple different videos already, and you may not have watched them in the same order, but please make sure you watch them all so that you get it. So all of these ones are looking like 1 plus. These ones are all looking like 2 plus. And then over here we get our 3 plus. This one is our 4. We like to share for 4. This is 3 minus, 2 minus, 1 minus. And these ones over here are our full and happy snobs over here. Oh, you can't see that. Full and happy snobs over there. So the table shows that the most common ions that atoms form when they give up or take electrons can be written in the top right of each symbol of the element. Some atoms can form ions of different charges, such as iron. So these ones right here, the ones that form different ones, we're going to do this a little bit later. We're going to do it, but we're going to focus on it a little bit later. But these ones in here, these transition elements, they tend to be the ones that can do more than one. And we do them, but the answers are on the periodic table, so you don't have to stress out too much about how those will work. And then this says, what else do you notice about the periodic table? So we've done this multiple times now, and like we're going to do it again, but this is group 1 has 1 plus, group 2 has 2 plus, group 13 has 3 plus, group 14 has nothing, it's going to stay neutral, group 15 goes to 3 minus, 16 2 minus, 17 1 minus, and then 18 is full. So also metals are positive, or our cations, and our nonmetals are negative, and our anions. All right, so what type of ions do the different elements form? So we're going to go through this together. Just going to see if we can focus this a little bit better. I will say the words out loud as I write them, but you will also need to maybe just look at the sheet afterwards if you're struggling with it at all, just because it might be really hard to see. I am doing my best. I think we'll also have this complete table up here at the end. So what we're going to do is we're going to start with chlorine. So chlorine is here. Chlorine has 17 protons. And when it is an atom, it has 17 electrons. It has, because it's in group 17, you guys can't see this, group 17, it's right here. Group 17 means that it has 7 valence electrons, and it is a non-metal. So the question is it going to be easier for it to gain 1 electron, or is it going to be easier for it to lose 7? So in this case, it's going to be easier to gain 1 electron. So it will now have 17 plus 1 equals 18 electrons. So it has 18 electrons and 17 protons. So it's going to have a charge of 1 minus, because it has 1 extra electron. So it will become Cl1 minus. So to find the charge, it's how many more electrons and protons, and if you have more protons, it's positive, and if you have more electrons, it's going to be negative. So that's how you determine the positive or negative, which one you have more of. So we're going to keep going. So magnesium is here, which is in group 2 of our periodic table. It's got 12 protons, which means it should have 12 electrons. Because it's in group 2, we know it has 2 valence electrons. It's a metal, as it's on the left side of the periodic table. And therefore, it has 2 electrons in that valence shell, so it wants to get rid of 2. So we're going to lose 2, which means we've got 12. 12 minus 2 equals 10 electrons, so we're going to have a charge of 2 plus, which would be Mg2+. So this video is going to run out of time. So I'm just going to quickly go through, then I'm not going to have time to finish them. I will write these out and I will post the rest of this for it, and then we'll do the next video.